Hi everyone, my name is Monica, and today I'm excited to present our work titled OVFact, Measuring and Improving Open-Vocabulary Factuality for Long Caption Models. This research is a collaboration between Warsaw University of Technology and Google DeepMind. In this work, we tackled the problem of assessing factuality of VLMs for long captioning in an open vocabulary setting, which still poses a challenge. Prior works, such as Chair, Throne, or Aloha, mostly tailored for measuring hallucinations, only partially address this problem. They are either limited to certain concepts from downstream datasets. They typically do not measure how descriptive a produced caption is, therefore promoting short captions, resulting in better metrics for non-descriptive captions. Only Throne looks at recall as a complementary measurement, ensuring produced captions are descriptive. They do not always leverage open source tools, making the metrics inaccessible without specific subscriptions to closed source models. And finally, to reliably measure factuality, they strictly rely on ground truth annotations, and this is particularly limiting in two aspects. It's impossible to apply these metrics to datasets of automatically generated, typically hallucinated captions. And second, it's impossible to scale them to millions or billions of samples. In this work, we propose OVFact, a fully automated metric to assess factuality of long caption models that is open vocabulary, takes recall descriptiveness into account, is built purely of open source tools, and is fully reference-free. How do we achieve this? Our method works as follows. Given an input image and its corresponding caption, we first parse the caption using an off-the-shelf open-source LLM to extract nouns with their corresponding attributes, which we further refer to as candidate entities, or C. Having obtained such candidate entities, we then use open vocabulary tools to verify which entities are actually present in the image. This yields a list of grounded entities. Based on this subset of grounded entities, we can simply derive a precision metric that measures the ratio of present objects with respect to the total number of entities from the caption. To ensure our method promotes descriptiveness, we also propose a second component to our metric. We first define a large vocabulary of concepts V and prompt our grounding tools to verify presence of each one of the concepts from V, obtaining a subset R of open vocabulary grounded concepts. We then encode candidate entities and grounded open vocabulary concepts using an off-the-shelf text encoder and calculate similarities between all the concepts in C and all the concepts in R. We finally define our second component, recall, as an average maximum score of each concept in R with respect to concepts in C. Our final metric that balances both components, precision and recall, is then defined by an F1 score. Note that our method is flexible enough to work when reference entities are given by ground truth by simply replacing R with ground truth entities. Nevertheless, the strong advantage of our method is actually its applicability to scenarios when we do not have such privileged annotations. For example, one of such applications is data filtering in large-scale training scenarios. Specifically, given a large database of long automatically generated captions, we can apply OVFact as a scoring function, which in fact is a continuous scoring function to each one of the samples. We can then use the score to filter out samples with low precision and recall measured by OVFact. And then we can train a VLM only on high quality subset of the data. And that's exactly what we did in this work. We present the results of filtering of shared GPT-4V dataset for different data ratios, with zero-shot evaluations on Dochi test dataset and localized narratives val set, averaged over 3 training runs. Here, the dashed line indicates model trained on full shared GPT-4V dataset. As we can see, OVFact significantly improves on factuality over all reported baselines and prior work, and particularly as we filter out more examples, thus resulting in a smaller, higher quality training set. And we highlight that our gains in factuality come without compromising descriptiveness or quality. We also measure zero-shot evaluation on the chair benchmark, highlighting that our filtering improves on traditional metrics as well. Our filtering method results in fewer hallucinations at the instance and sentence level of chair, maintaining or improving recall of generated captions. We also discuss a trade-off between precision and recall as an ablation of our metric. Specifically, we train a VLM on filtered subsets of shared GPT-4V and evaluate models zero-shot on the Dochi test set. Note that here the top right corner is the best. We observe that filtering with full OVFact, so here in purple, yields models with the best trade-off between precise and descriptive captions. We present a qualitative example comparison of 2 trained VLMs, PADI Gemma 2 here in this case, where the top example is the model trained on the full training set, and the bottom one is the model trained on our OVFact filtered training set with 5 times less training data. Both models are run zero-shot here on the localized narratives dataset. We observed that our model outputs captions with consistently lower rates of hallucination, without compromising descriptiveness. We also conduct human evaluations to verify whether our metric aligns with human judgments. We extend the initial side-by-side human study proposed in Dochi, which compared the outputs of a fine-tuned PADI 5B against each of the 3 other state-of-the-art models, including GPT-4V, Instruct Blip, and Lava 1.5. We report the agreement rate of our method versus the judgment of human annotators for which model's output has higher precision or recall, and we show results for all 6 pairs of the 4 models. OVFact significantly improves on capturing precision compared to the state-of-the-art prior work Aloha, even when provided references from ground truth captions. In contrast, our metric is fully reference-free. We also report the agreement between our method and human recall judgments, demonstrating a high level of agreement. Finally, we also include the results for CLIP image score, which incorporates image generation models to indirectly measure hallucination, and we find that our method substantially improves over this technique as well. And this concludes my presentation. So we introduced OVFact, a method for measuring factuality of long captions, which is open vocabulary, open source, and fully reference-free, thus not dataset specific and applicable to large pre-training settings of captioning models for effective filtering. For more details, make sure to check out our paper, and thank you for your attention.